Now let's take a look at recursion just for a moment. Historically, that was the only way that we could do basically anything in Lisp was with recursion. And we're all familiar with recursion. This is how we write a recursive function in Lisp. For example, this is a factorial function where we have, if, uh, if n is less than or equal to 1, then we return 1. Otherwise, which is that t there, otherwise we multiply n times recursive call of factorial on n minus 1. Okay? And as you'd expect, let me just type that in real quick. The fun fact. Sorry. Always exciting to watch somebody program, isn't it? Especially when they probably make a mistake. You should have been at the actual Lisp review. I was not able to do anything without getting an error. Probably demonstrate that again here. So, as you'd expect, right? Now let's trace that and see what it's doing. Showed you trace earlier. And that's what a trace looks like here. And notice it's doing the same thing. It's just expect, right? You get there, it returns 1, and returns out of that. And so it's a nice way to see the recursion in action. And a nice way of debugging things as well. The Lisp has a pretty extensive debugger, and I encourage you to take a look at the documentation that comes with your list to see what that's for. How do we use it, I mean. Okay? We know about tail recursion. We know about direct versus indirect recursion. Direct recursion is when a function calls itself. Indirect recursion is when it calls another function that then calls itself, or calls it. Tail recursion, we mentioned in 140 and 301. Some of you didn't have those classes, or may not have. This is an example of a tail recursive list. It's the world's most useless list that just a function that just prints this list. And so, given a list, if it's a null list, it returns nil. Otherwise, it prints the first thing in the list and then calls itself on the cdr of the list. Okay, this is tail recursive because the very last thing the function does is call itself. Okay, why would we use tail recursion? It's much, much, much faster than doing non-tail recursion, because since this is the last thing in the function, in the function here, then when Lisp gets here and gets ready to do the recursive call, instead of doing a call, it simply sets the parameter L to be this thing and branches to the top of the function. Okay? And so now this has essentially turned it into a loop in assembly language, and yet it still has the power and the beauty of recursion. So you can see if I define Fibonacci, Fibonacci is a sequence of numbers where each number is the sum of the preceding two. The most natural way of doing that is recursively. Okay? This is non-tail recursion, where I've got to do this fib, and then when it returns, do that fib. This actually is a horrible case because it gives rise to an exponential number of calls. This is tail recursive, the same thing, a way of doing it. It's kind of, you'll have to take a look and see if you can figure out how it does it. If I type fib 30 here, it takes 7 seconds. That's a long time for doing 30 things. If I type fib tail of 30, it takes a little less time, as you might see. And so it's much, much faster. Okay. Now, mapping. Mapping is another way of doing iteration. You can think of it. Lisp has a bunch of different maps functions. The one I typically use is mapcar. What this does is it takes a function like car or whatever. Let's do cdr just for fun because I'm doing car there. It takes a function and applies it to the elements of a list. So if that's my list, it's going to apply cdr to each one of these. It's going to take the values that result from that and make a list out of them. Okay, just like I showed you up here. Okay, usually quite handy to do. All right, do list is an iteration construct that's built in. So if I do list thing in this list and then say print thing, it does what you'd expect. Okay, very simple. Do times is a very simple other for loop. Goes from 1 to 10, so it's extremely simple. Okay, up 0 to 9, sorry. Why did I think 0? Oh, anyways, does from 0 to 9. So this is what you'd expect, but still very simple. If you want to use more complicated Lisp, though, loop, I'm sorry, loop by itself is built into the language as an infinite loop, but it didn't take people long to decide to make a more complex loop. They did this by using Lisp's extensive macro facility, which is something that we'll talk about in a moment. If you think about it, what a macro does in other languages is just substitute something everywhere it sees something else. So a macro in C, for example, you use the pound define or the hashtag define something, the hashtag define A3, and everywhere in the program it sees A, it substitutes in 3. Lisp takes that to an extreme, and we'll talk about that in a moment, but the macro facility can be quite complex and can do a lot of stuff, and loop macro is an example of that. I usually tell people if they're going to try a loop, just go ahead and start it. Just start typing. It'll usually figure out what you're meaning because it's quite complex, quite powerful. I mean, it is complex, but it's quite powerful. It's also not very Lispy if you take a look at it. What this does is loop through from I to 1 to 5, simultaneously looping for element in this. This is what it's going to do. It's going to print the element print I, and then it's going to collect, meaning it's going to collect these values and return them as the value of the loop. Everything returns a value. Okay. By default, loop returns nil. So this is telling me take those things, put them in a list, and then return them. Okay. That didn't show it. Let me go back one here. Whoops, just one. All right. All right. So over here, let's see. It's a little verbose. Let's do a print I again and collect. If I run that, there's what it's printing, there's what it returns. Okay. You can make this into a while loop anywhere you want. Let's say while I is less than 4, and that just does part of it. Okay. You could put several things there. You could put several whiles. You could put something like this: when I less than 4, do print hello. And this actually may not do what I'm expecting. No, it didn't. It gave me an excellent problem there. No, it didn't like me. Okay, maybe you don't want to do that part. You don't want to do that one. Never mind. If I do that, though, what am I doing? I did something stupid. What did I do? Well, I should probably see what it's telling me, shouldn't I? Oh, variable is unbound. Okay, well, that's interesting. Is not a prefix language. It's not a infix language. Boy, how long I've been using Python too much lately. There we go. So now that's what I should have been doing. Why did some of you tell me about that? Okay, so it's every time that I is less than 4, it's printing high, and otherwise it's doing all that. Okay, I see quite a few things. You can also do this with Q, for example, whatever you want, for I from 1 to, let's go back up here, and Q equals, with Q equal 1, right, 1 to 10, sum, first of all, we're not going to use Q on this one, sum I is another way to do that, and it summed up the variables, summed up the I from 1 to 10, but if I want to do that myself, I can do this, do set QQ plus QI, and then finally return Q. If I don't do that, it'll give me oh, good, it got a different value. Oh, because it's set to 1. If I don't do that, then it just returns nil. Okay, all right. Probably beat that dead horse too much. Numeric operators are the usual stuff that you might expect. With respect to string operators, there's quite a few. Strings are primitives. They have a different suite of operators than lists. So you take the subsequence, you can do searches, you can look at, if you need regular expressions, either look online or talk to me. There are quite a few good regular expression packages for Lisp. Now, formatted I/O takes this form, takes a stream, and T just means the standard output, the terminal. And if I just give it nothing, it'll just print that. But if I give it a format specifier, then it's just like printf in other languages or whatever. It's going to insert that in there. Now, there are a bunch of these different format specifiers. So I can specify this, for example, and put in a string here, and it'll put the quotes in. If I specify it as getting rid of the quotes, it get rid of the quotes. There's tons of these things, including things like printing things out in Roman numerals or binary, all kinds of things like that, and very complex things if you want to take a look at them. Okay. With files, open and close are the primary ways of doing it, or the simple ways of doing it. Open will return a stream, which is like a file handle in other languages. It's a pointer to the stream that's hooked to that file. But the best way of doing it, in my opinion, is use with open. This is an example of a form that you'll see often in Lisp, with dash something. And usually what that is doing is specifying something is true until you exit the form. In this case, it's saying a file will be true, with open file, I'm sorry. The file will be open until you're ending. And then when it hits the closing parenthesis, it closes the file. This has an unusual form. First of all, it takes the name for the stream, so let's say n. And there's a lot of, and it takes a file name. So temp foo, we'll say. Let's say if I've got temp foo. I do. Let's make something else. Let's insert my, oops. We'll insert my bash rec there. Okay, but don't worry about that if you know what it is. So I'm going to read that in, and then I'm going to loop for, with line, so a new variable line, while not equal EOF, end of file. You can call it whatever you wanted here. Set Q, we'll explain this in just a second. Set Q line read line in. Oops. We'll explain it better than that in a moment. I've got my screen so tiny here that I can't see. You have to do a lot of things, like a lot of lines for one line. Okay, so that's that one. All right, do, and now I'm going to print the line. Or let's not print it. Let's let's write line. And I'm just going to write it to the standard output. Okay. What this should do is print the file. Okay. What it did up here then was it opened the file. It opened the file temp foo. It used a stream in to talk to it. Then it looped, created a temporary variable line. It's going to loop until this condition is false. This condition says, notice this is a functional language. It's the first time I'm really using the aspect of functional languages that we talk about. This thing is a Boolean, but it's saying, well, this thing is not true. This thing is going to be true when this symbol, this keyword symbol, EOF, is equal to this thing. Well, this thing is this set Q, setting line to be equal to something. And what I'd set line to be equal to is read line. I'm going to read in. This says, don't give me an error if there's end of file, but instead return this thing. And if I put my cursor in there, you'll see down at the bottom here, it gives me the argument list. So there's the stream, and EOF error is normally yes if it hits EOF, but I set it to nil, and this is the value that's returned. Okay, we won't worry about recursive P. Okay, so that's going to read each line of the file into line until it's EOF, until it's end of file. That's going to put this symbol EOF in line. It's going to check to see if that's true. It is, and it's going to see then it's going to exit. Okay, and then now that file is closed. All right. Now scoping. Every language needs to talk about scope a little bit. Scopes. Lisp is a lexically scoped language. You all know what that means, hopefully. Scopes are opened when you open a function, so the parameters are local variables, and you can create new local variables inside with a special form. The only exception to something being lexically scoped is if you define a variable or set something to something at the top level. If I define a variable, say hello, we usually make global variables with a star on each end just so they kind of stand out. If I set that to 1, and let's do scribe hello. Oops. And it tells me it's a special variable whose value is 1. Okay, that's cool. What that's telling me is that this thing is dynamically scoped. And so those of you who know what that is, this is the way to get them. And you can try to use a dynamically scoped variable. Most of the time you're going to want to deal with lexically scoped variables because, as you remember, if you took my 301 course, basically I explained that dynamic variables are essentially the work of the devil in most situations, and so we try to avoid those, but there are times you need them, and this is how you do them. There's another defining variable thing that can be at the top level. It's called def parameter, something like that. They're the same. They both create a special variable. The difference is that if I were, say, to put a def var in a variable, and sorry, it's been a long day. If I put a def var form in a file and load it, and then later change, for example, hello to be something else, and then reload the file, it won't overwrite the value of the variable with what was in the file. So defining the variable, giving the initial value, but then I can do whatever I want with it. It won't be changed by future def vars. Def parameter, however, is saying, yes, make this a special variable, but if you see this def parameter again, change the value of it. And so if I put this in a file and reload the file, it'll reset the variable to whatever it was. Okay. Now, very often you want to create. This is really a nicely formatted slide, isn't it? Very often you want to create new variables, local variables. And one way of doing this is with the let macro, which you see here. The format of that is let, and then there's a list of variables that can either be uninitialized, like this one, b, and that will take the value nil, but don't count on it. Not all lists, they're not required to make that nil. They all do, but technically they're not required. And the second, then, a second variable it creates is a, but because I've got these parentheses and a value around it, it initializes a to 3. Okay, so here, this a and that b are different than the a and c that were created outside. And typical thing here, I've got a print a inside, c and a inside of there, and then a outside goes back to its original value. Okay, because they're different variables. All right, if you have local variables inside of a file, you always use let. Otherwise, they become global, and you can have really bad side effects. If you need to use a global variable, then use def var and know what you're doing. Okay. You can also use this to group a group of forms, and so we could do something like, whoops, not like that. If t, well, 5 would work. Let, don't need anything there. Well, that works just fine. So I've grouped two things here, right, inside that let. A cleaner way of doing that, because this is opening a new scope, and that can take a bit, a cleaner way of doing it is use prog in, and prog in, I can just put things in there, the forms in there. And it returns the last thing, okay? Obviously, that's the world's stupidest thing here. So I'd do something like that maybe, right? So now it returns 12, but A now has 7 in it. I can also do prog 1, and now that returns 7, okay? It does both forms, so if I do this, it returns 7, but B also has the right value. So sometimes that's useful as well. All right. Association lists are lists that have this form. We think of as key value pairs, so like a primitive database, basically. There's a special function to deal with these that will reach in and check the car of each of these. You could use member as well, but this returns the element of the list that has Turner, for example, as the first element. Okay, so it returns this guy, right? The reason we use catter oftentimes is if we want to get the value itself. So if I say catter assoc white A list, so that tells us it's going to return this piece, and then catter is going to return the second thing, and we'll get that. Okay, you can build them by hand, or you can do whatever you want with them. You can define them as a however like this with a quote whatever. Okay, now you can maintain these. You can change what's in here using setf, replac d, and replac a. This is replace the car, replace the could, or replace the car. I tend to use setf because it's less dangerous, less confusing. So if I have this, let's say a list, that you can call it whatever you want. Let's call it something else. B a1. You can make these dotted pairs as well. Works just as well. In fact, that saves some space. So there's my a list, and I can say assoc b. What do I call it? I called it b. Okay, and that finds that one. And I can do catter that. That gives me the thing. And I can do set f for. And now if I look at b again, and notice what it did, it changed that value there. Remember I said set f can anything it can find basically. There's some limitations, but anything it can find a pointer to it can change. And so it set that thing right here to be 4. Okay? All right, property lists we're not going to worry about. You can read about those if you want to.